just did a good thing. I don't regret this thing at all. And you're wondering what it is. I'll tell you what I did a good thing.
Hey all you cool cats and kittens, this is Miss Carpenter, and today I want to show you our newest addition to the Big Cat Rescue. This is Tez, short for Tezcatlipoca. Tez is a gray, long-haired domestic house tiger kitten. She's about 5 weeks old, which is prime cub petting time. Can you say hi, Tez? Let's get started with today's lesson. I'm going to introduce it to you, and throughout the lesson you will be getting to see much more of my amazing fur baby. Also, a disclaimer, if you think that I'm purely using this kitten to get you to watch the math lesson this week, you're not wrong. Make sure to please tune in and please get your analysis questions done. Alrighty guys, we are in week 6 and our title for today's lesson is How Do I Find the Missing Side? As always, I'm going to start with our introduction and then we're going to jump in. Architects create scaled plans for building houses. Artists use sketches to plan murals for the sides of buildings. Companies create smaller sizes of their products to display in stores. Each of these models is created to show all of the information about the real object without it being the actual size of the object. For example, you guys know that you're getting a new school in a few years, a new middle school, and when you create that middle school, you have almost like a smaller scale version that you can look at and plan before the actual large version is built. Now, if that small version wasn't built to scale, then the big version would be all messed up, so it's very important. Today you will discover strategies that you can use when you are missing some of the information about a set of similar shapes. As you work, look for more than one way to solve the problem. Alrighty, here is our big question of the day. How do we find missing side lengths of a similar shape? Keenan loves trains. During quarantine, he has decided to build a model train of the Rio Grande, a famous train in Colorado. Use the information below to help him know how big his model should be. Now, this is really important, guys, so you have to pay attention to this information in order to be able to solve the problem. The first piece. The real track has a width of 3 feet, which is 36 inches. His small railroad track has a width of 3/4 feet, which is also 0.75 inches. And the Rio Grande train, the big one, he wants to model, has wheels that are 44 inches high. So right away, we realize that we are dealing with the unit of measurement of inches, and we're going to use that information to solve our problem and the questions that they ask below. Before we go and start to solve the problem, though, I want to go over with a highlighter which measurements are the big pieces and which measurements are the small pieces so that in our brains we can just keep them there. So the real track has a width of 36 inches, and the fake track, the small railroad track, has a measurement, a length of 0.75 inches. Now, the Rio Grande train, the big one he wants to model, has wheels that are 44 inches high. And we don't know how high the wheels of his model train are going to be because that's going to be the small version. So let's flip to the next page and see if we can find the scale factor using the drawing that's on the page, on the next page. Okay, so now we have our sketch in front of us, and we see that the big tracks are 36 inches, and the small tracks are over here at 0.75 inches. So in order to find the scale factor, we have to go from the big tracks here to the small tracks. We have to figure out what to multiply 36 by in order to get 0.075. Just like we did in the last problem, I'm going to highlight the 36 inches in blue and highlight the 0.75 inches in green, and then I'm going to highlight the word scale factor just in case I need a refresher on what that word means, or a reminder of what I'm trying to find here. And we have the new, and this is just like what we've done before. We have the, oh, I'll scooch it over a little bit. We have the new, and we have the original. And we've been doing this for a long time, guys. In almost every lesson about scale factor, I've shown you guys this kind of setup, and the reason that I show you it is it's the easiest way to keep track of what you're doing. So we want to find the scale factor, so we'll put our original down as 36 inches, and we will put our new down as 0.75 inches. Okay, and then this scale factor is how to get from one to the other. And again, we have to multiply. Always remember that. You have to multiply. You can't divide. You can't add. You can't subtract. It has to be multiplication. And now we're going to work with that trick that I showed you guys last time. I'm just going to write it right here. Our little trick. You could guess and check between here and just try to multiply something by 36 in order to get 0.75. But the trick that I taught you guys last week is if you do the new number and you divide it by the original number, you will get your scale factor. I'm just going to write scale factor as SC for now. Okay, so that's our trick. So if we use the numbers that we have in front of us today, that would equate to 0.75 divided by our original number, 36. And that number equals 0.0208. And it keeps going, but I'm going to cut it off right there. For my sake, I'm going to box it so that I remember that that's the scale factor. I'm also going to write it up here because this arrow means that you are multiplying 36 by something. That something is 0.0208. Now, you could have probably guessed and checked and found that number eventually, but it would have taken you a pretty long time. So let's use that information that we just found. Answer this question here. What's the scale factor? We know the scale factor is 0.0208. And for those of you that did this completely out on your calculator, it's 33 repeating, and it just keeps going on and on and on and on. Alrighty, and we're going to use that information now to answer the analysis questions that you have. So if you have access to Google Classroom, remember to go on and turn these in after you've written them down so that I can see them online and give you feedback. Alrighty, now we are going to actually explain the analysis questions. It says, what is the scale factor to go from the big train to the small train? A hint, it would be the same scale factor that it was for the tracks, so right up there. Okay, so I'm going to write that down and do a little bit of highlighting so that things make a little bit more sense to us. Before, we highlighted the small train in green, so we're going to do that again. We highlighted the big train in blue, and we highlighted the scale factor in purple. All right. So our scale factor is going to be exactly the same that it was in our previous problem, which is right here. So I'm just going to write 0.020833 repeating. And usually I don't answer these for you guys, but in order to answer this question correctly, you are going to have to know the scale factor. So I want to set you up a little bit here. It says, what will the wheel height of the small train be? Remember, small train is green. And the big train wheels, that's blue. Blue is our original. Green is our new. And here's the scale factor. We don't know the new number. That's a mystery. But we do know the original for the big wheels. If you look back at the last page, it said 44 inches. Now, we have our purple line here. Remember, you multiply by this number. I want you to do it and show it yourself, and then find this new number, which will be the height of these small train wheels. And it should be a pretty small number because we're multiplying by a pretty small number. All right, if you have finished your analysis questions, make sure to go online and turn those in. If you have not, you can take a little bit more time on them and then turn them in, or you can just turn them in after the lesson. We're going to start off with this new problem, 6-99, and it's talking about a Guess My Shape game, and we've played some of these before. This one's a little bit different. Heather and Cindy are playing Guess My Shape. Heather has to describe a shape to Cindy accurately enough so that Cindy can draw it without even ever seeing it. Heather gives Cindy these clues. Clue 1. The shape is similar to a rectangle with a base of 7 centimeters and a height of 4 centimeters. Clue 2. The shape is 5 times larger than the shape it is similar to. Has Heather given Cindy enough information to draw the shape? And if so, sketch the shape on your paper. If not, write a question to ask Heather to get the additional information that you need. Alrighty, the way that I want to start this is I want to break it down to its most basic pieces. We're going to say that the base is 7 centimeters. We'll highlight base as well. Okay, and we're going to say that the height is 4 centimeters. Now when I draw this shape, this is what I'm going to do. Get it level there. So I'm going to, this is my shape number 1, right? This is the first step. I have a base of 7 centimeters, which also means that up here is going to be 7 centimeters. And then I have a height, okay, so my up and down, of 4 centimeters. Oops. And it tells me that the new shape is 5 times larger. So what I'm going to do is I'm going to take this value, 4 centimeters, and I'm going to really quickly, this is just the calculations that are part of number 2, I'm going to do 4 times 5 and get 20 centimeters. And then I'm going to do 7 times 5, and I'm going to get 'This is why I shouldn't record with a cat in the room, guys. She's chewing on cords. Alrighty, and then we have 7 times 5, which equals 35 centimeters. Now we're going to redraw our base and our height. So our base is going to be this number right here. That's going to be 35 centimeters. And that's going to be 35 centimeters. And then our height is going to be this 4, right, that we changed to 20 centimeters and 20 centimeters. So, there we go. It's as easy as that. You are just multiplying the lengths and the height by 5, and then you're getting your new shape. All right, our next question is use what you know about Guess My Shape to describe the mystery shape below. Pretend that Miss Carpenter has not seen the shape below, this one, this triangle, and write me a list of clues to go from a similar shape that you make up to the shape that's down below. After I follow your clues, I should end up with the shape that we all see here. You do not have to use all the clue spots below. So if you want to just include 2 clues like they did up here, that's totally fine. I don't mind at all. So let's get started. The wording on this sounds a little bit confusing, but I'm going to explain it a little bit more in depth. Basically, I just want you to use these numbers to almost reverse into your quote-unquote original shape. So for me, this is what I did. I took 12, 16, and 22, and I divided them all by 2. So I'm just going to show you guys what my original would look like. And if you see a paw in the video or some ears, it's because my cat is diligently trying to help me teach you guys this math. Okay. So 6 centimeters. And then we have, oh, she agrees. Yep, checking my work. And then we have 11 centimeters. And then we have 8. There she goes. She's checking over all our work, guys. She's so helpful. She's a math cat. Okay, and then we have 8 centimeters. So I just basically divided by 2 here. Do you agree, Tess? Do you agree? Yep, she agrees. Okay, so now, this is my original. I want to start with these numbers and then get you guys to a point where you can guess these numbers. So let's do this. I'm going to tell you that the shape is similar to a triangle with side lengths and then I'm going to list them: 6 centimeters, 8 centimeters, and 11 centimeters. Okay, because these two triangles, they are similar. I just divided every single side by 2. So proportionally, they're the same, even though they look a little bit different. And now I'm going to tell you that the shape, and the shape we're talking about, remember, is this one. The shape is 2 times larger than the shape it is similar to. Tez is going over my work again. What do you think? Did we give them the accurate clues? Alrighty. You guys can create whatever shape you want, whatever triangle you want. You could make it bigger if you wanted to, as long as you come up with your own imaginary shape and somehow get here. I will ask that you not necessarily just copy mine. I really want to see what you guys can do here. So please try to be creative with this problem. Because they're the clues that you're creating, there's really no wrong answer. Next up, we have 6-100. Nick enlarged figure A at right so that it became the similar figure B, so A to B. His diagrams are shown below. Very first thing I'm going to do before I even read any of this, guys, I'm going to pull out the highlighters and we're going to do some corresponding side length highlighting. So the 4 millimeters is similar to the 10 millimeters. The 7 millimeters is similar to this X over here. The bottom, which does not have a measurement, is similar to this bottom or this base over here. And lastly, this 2 millimeter is similar to this 5 millimeter. So the reason that I'm doing this is because oftentimes when shapes get more complicated like this, sometimes we can accidentally go from like this side length to this side length, and then our ratio and our scale factor is all messed up and all over the place. So I like to highlight just so that things are clear. We're going to write down all of the ratios that compare the corresponding sides of figure B and figure A. One example would be 10/4. And that just shows this 10 millimeters over this 4 millimeters. So we're actually going to write that down. And because I have it highlighted pink, I'm going to write it in pink. I have 10/4. All right, my next one I'm going to write in purple. And my purple ratio is going to be 5/2. And my blue ratio is going to be x/7. And you'll notice something. You will notice that all of the side lengths from B are over all of the side lengths from A. And if you remember, a trick from last week is that if you put the new, or this B, for example, so we're going to write new B divided by original, which is A, then we know you get the scale factor. We just did that in the last problem. Okay, so 10 divided by 4, 5 divided by 2, x divided by 7. When we have fractions like this line just means divided. So really, when we're showing these proportions or these ratios, we are just finding the scale factor. Alrighty, for this next problem, we know the scale factor. We've found it already. And we also know that for our, we'll do original here. And we'll do new right over here. Okay, we know that our original is A. And we know that our new is B. And in order to go from one to the other, like we said in the last problem, we have to times by 2.5. So we also know, if you look at the triangle that we were just doing, our original has 7 millimeters and has x for B, which is really just a blank. We don't know what that number is. But we can find out because we have to times 7 by 2.5 in order to find x. And when we times 7 by 2.5, we get 17.5. Oops, it's a little cut off. Hopefully you can see it. Okay, we get 17.5 for x. And what I like to do personally, you don't have to do this, it's something that I just like doing, is we're going to go back to our picture of these two shapes. And because I just found out that x equals 17.5, I'm actually going to write it here. Okay, and this right here, guys, I know I didn't write it below, But this right here is very important to me, and I stress it in every lesson. I don't want any naked numbers.
What's your profanity?
And what that means is whenever you have a number, you have to have some sort of measurement next to it. Because if you don't, I don't know if you're talking about cats or doorknobs in your house or cars that you've driven in your life or the amount of hairs that you have on your head. I'm not sure. So if you don't put down the numbers, I don't have all the information that I need. So please be complete. No naked numbers. Alrighty, so now we're actually going to use those ratios to find our scale factor using our trick. So I'm going to take this proportion, this ratio, 10 over 4, and I'm going to turn it into 10 divided by 4. Not going to find out what it equals just yet. And then I'm going to take 5 over 2 and turn it into 5 divided by 2. And that's 2 sample sizes. X, we could do x divided by 7, but we don't really need to do that right now. I just want to see if these two match, because if they do, we know we have a constant scale factor. So let's look. 10 divided by 4 is going to be, if you put it into your calculator, is going to be 2.5. And same with 5 divided by 2 is going to be 2.5. So we know that our scale factor is 2.5. Now that's very useful because what that tells us is in order to go from A to B, we have to times this number by 2.5 in order to get this number. So let's try that down below on the next problem. All right, our next problem is 6-101. Fatima solved for P, sorry guys, teacher fail, in the diagram of similar triangles below and got P equals 30. Looking at her answer, she knows that she made a mistake. Before we even look at anything, let's do what we always do. You should not be surprised by this anymore. The reason that I want to do this with you is because this one is a little bit more funky than the other ones because the triangle is turned. Usually our shapes are not rotated at all, but now they are, so it's especially important to do this highlighting mechanism so that you know the 50 and the 75 are matching and the 45 and the P are matching. Okay, so they're corresponding side lengths. All right, now you have a series of analysis questions to complete here. Again, you can answer them here and then put them online, or you can do all the work online. It doesn't matter as long as I see some sort of turning it in online so that I can give you feedback on it, because I'm not going to give you the actual answers for these. I kind of want to pick your brain and see what's in there. So our first question is, what would make Fatima think that her answer is wrong? I want you to think about this logically. If you're going from a small triangle to a large triangle, the numbers are probably going to mirror that. They're going to go from small to large. Now correct Fatima's mistake. What is the scale factor? The multiplier to go from the small shape to the large shape, which means that you're going to have to take some number like, I don't know, 50, which is in our pink highlighted zone, and you're going to have to go to 75, and you need to find the mystery multiplier that goes here. How do I get from 50 to 75 by multiplying? That's what you're answering, and that's how you're going to find your scale factor. Then once you find your scale factor, You're going to take the 45 that you see, which matches up with the P, and you're going to use that multiplier, the same one that you just found. Okay, to find this mystery value that is P. Alrighty, that is your job for the analysis questions. I want you to do your best on these. I know that sometimes they're hard, but they push you a little bit to the limits for a reason, and I do that on purpose. So do your best to answer these. I'll give you some think time, and then we'll finish up the lesson. Alrighty, 6-102 is our very last problem today. It's a writing task, which I know a lot of you just took a big sigh and you went, I don't want to write about math. But sometimes we have to, and it's good for you, I promise. Imagine that you are going to teach someone how to find a missing side length, like we did in the problems above. How would you summarize the steps, and what process do you have to go through each time to find a missing side length? You can make a set of shapes as an example if you would like as you write out your steps. So you are writing to someone, let's just pretend they're a 7th or a 6th grader who's not in our math class, and you want to show them how to get from one shape to another and how to find a missing side length. So I'm just going to do a really basic example right here. I have this triangle, and for this triangle I know that I have a 2, a 4, and an X. And then I have this triangle, and I know that I have a 6, a 12, and we'll say a 15. You might notice that when you go from this side length, this 4, which corresponds to the 12, when you go from 4 to 12, you are multiplying by 3. When you go from 12 to 4, you're dividing by 3, right? It goes both ways. The 2 to the 6, the same thing. 2 times 3 is going to equal 6. But if I go the opposite way, it's going to be 6 divided by 3 is going to equal 2. Now when I look at my 15 and my 6, I know that if I multiply x by 3, just like all the other ones, I'm going to times x by 3, I get 15. I still don't know what x is. But if I, like I did from 6 to 2 and 12 to 4, if I divide 15 by 3, I'm going to get x. And 15 divided by 3 equals 5. Okay, that would be a diagram, and you can write that out and explain what you did. You found the scale factor there. We did that really fast, really easy. And if this is kind of starting to make a little bit of sense, but you're still struggling with it a little bit, that's okay. We're going to be working with it more. I hope you guys all have an awesome week. I apologize for not getting these videos out sooner. In the process of moving and some other remote learning stuff, it just kind of fell to the wayside, but they will be up from now on. I hope that you are staying safe, staying healthy, and please call me or text me or email me if you need any help on these problems. Bye guys, thanks for watching. We'll see you next week and we will do another lesson. Hope you guys are doing well, and we'll see you later.